Welcome to this tutorial showcasing the Renesas RA4M1 microcontroller for EV charging station control. In EV charging stations, CAN bus is used for communication between control boards and devices. RS485, also known as Modbus, connects AC and DC energy meters. RS232 enables serial communication with external software. Switches are used for user input, while LEDs and relays provide visual feedback and device control. Together, these components form the backbone of an efficient EV charger control system. Here we have two identical systems, each equipped with exactly the same components. At the heart of each system is the powerful Renesas RA4M1 series-based microcontroller. We also have an RS485 connection here for reliable long-distance communication. Here, we are using CAN bus modules which act as transceivers for communication between the boards. We have an RS232 module that enables simple serial communication with PC. These boards feature both toggle switches and push buttons for user input. There are LEDs for visual feedback and relays for control functionality. The only difference between these two boards is the placement of the components for better flexibility. Originally, we followed a standard layout, but due to space constraints, we rearranged the components. Some of the I/O ports are connected to the LEDs for display purposes. Other ports are connected to the relay bank for control operations. Switch inputs from one board are sent to the other board using CAN bus communication. The switches on board A control the LEDs and relays on board B through CAN bus data transfer. RS485 is configured on both boards to send and receive data seamlessly between them. You can send data from one module to the other using serial port 1, and vice versa. This setup gives us control of LEDs, relays, switches, and communication over RS485 and CAN bus. In EV applications, we use switch inputs to control relays or devices. This setup shows that clearly. If I toggle all the switches on the first board, you'll see the changes reflected on the second board. Similarly, toggling switches on the second board will change the LEDs and relays on the first board. Changing values here updates the LEDs and relays on the other board almost instantly, with minimal delay. In the next part, we'll demonstrate data transfer between the devices using RS485. We have two COM ports of PC connected to serial UART ports of MCU in each of the two boards. The data received from the PC is sent to another board using RS485 serial communication module. For demonstration, we are sending numeric data from board A to board B. Similarly, we are sending character strings from board B to board A. Both CAN bus communication and -485 communication are independent of each other as they are connected to different UART ports of MCU. Hence, we can communicate with multiple devices in parallel using different communication protocols. In conclusion, this demonstration showcases seamless control, communication, and data exchange between both boards. The system manages inputs from AC/DC meters, turns relays on/off, and connects other devices using RS485 and CAN bus. Thank you for watching. Like, share, and subscribe for more tutorials on microcontroller solutions for EV.